This video is all about helping you get Minecraft installed, orchestrated, and up and running on HashiCorp Nomad. How to run and install Nomad on Windows and Linux. And then I'll show you how to run Minecraft on Windows using the raw exec task driver and the Java task driver. And then I'm going to show you how to install and run Minecraft on Linux using the Java task driver without persistent volume mounts and then with persistent volume mounts. And finally, we'll top it off with how to run Minecraft on Docker on Linux using Nomad. But why use Nomad? Why go through all this trouble of setting up more software just to run my Minecraft server? I could just download server.jar on my computer, run it, open a few ports on my router, invite my friends, and call it a day. So I'm sure we're all familiar with this scenario, right? I host a server at my house, on my laptop or my computer. I go to bed, I go to school, I go to work. While I'm there, it crashes. None of my friends can get on their day off, and their day is ruined. So the reason we go through the trouble of installing additional software to then have run Minecraft for us is because it can fix this issue for us. Nomad has the ability to run our Minecraft server, but then constantly check to make sure that our Minecraft server is running in the state that we want it to. And this ensures that, if we're at work or school or wherever and our Minecraft server has an error and exits, Nomad can attempt to start it again. So Nomad is what we call an orchestrator. So if you're familiar with orchestrators like Kubernetes, it's similar but not the same. If you're not familiar with what an orchestrator is, let me try and draw a horrible analogy for you. So if we think about a musical orchestra, right? We have a music composer, they write some music, and then once they're done, they hand it to the conductor of an orchestra. And a conductor is basically the messenger for the composer. The composer gives the conductor the piece of music and says, turn this into reality. Tell the musicians what pieces to play. Make sure everything is in sync and in time. And so the conductor goes to his orchestra, his musicians, and he says, you will play the violins, you will play the trumpets, here are the notes you need to play at what times, and then everybody works together in sync. And then if there's ever a question of what somebody within the orchestra should be doing, they look straight up to the conductor of the orchestra who is standing up front, waving his fingers, and everybody knows exactly what they should be doing. So with Nomad, we also have a music composer, and that would be you or the person writing or describing their application workload, how it should be deployed, what resources, RAM, CPU, ports should it use, how should it be composed, right? And then we, the composer, take that workload and we hand it to our conductor, which would be the Nomad servers, the Nomad application. And then Nomad clusters generally have a few servers, a few conductors in their orchestra, and a bunch of clients, which would be the equivalent of our musicians. And so the Nomad servers or conductors would get this workload, and then depending on what we're doing with these workloads, the Nomad server would give it to the Nomad clients, the equivalent of the conductor giving the musicians the pieces of music that they need to perform their jobs. So what we're going to do as the music composers of our orchestra, we're going to write a Nomad job definition to describe how we would like Minecraft to run. And then we're going to give it to our conductor, the Nomad server, and then the Nomad server is going to give it to the appropriate clients to then run Minecraft. So with my horrible analogy out of the way, let's get into the video. So starting with the Windows install of Nomad, right, we're going to head on over to developer.hashicorp.com/nomad/docs/install, and I'll leave a link in the description of the video for this as well. But when we get here, we're going to go through the manual installation process, and we're going to do that for both Windows and Linux. Now, you do have the option of using Chocolatey on Windows if you have that package manager, but we're going to go ahead and do the manual installation. So go ahead and click on this precompiled binary link when you're here, and we're going to choose this Windows tab. And for the majority of people on Windows, like 99% of you, you're going to be using an AMD 64 architecture. So you're just going to go ahead and hit download. Now that's going to download that zip file somewhere on your computer. So for me, I'm on Chrome, and you can see the zip file has been downloaded here. And so that goes in my downloads folder within File Explorer. I go ahead and I open that up, which is the equivalent of unzipping it. And then I will see a file named nomad.exe. Now what you want to do, and I've already done this, is somewhere on your computer, and I'm doing this on my F drive, I've created a folder called Nomad, and I've already got some stuff in here from playing around on my own. Now what you want to do is you want to take that nomad.exe and you just want to drop it in that folder that you created somewhere on your computer. Now the next step is to add Nomad to our system path. So to do that on Windows, what we're going to do is we're going to look for environment variables in our search bar, and we're going to choose edit environment variables for your account. And we're going to choose the one that says path, and we're going to hit edit. Now what you're going to do is you're going to go ahead, and you can see that I already have it here, but let me go ahead and delete it real quick. We're going to hit new, and we're just going to choose the location, right? We're going to enter the location where we dropped the nomad.exe file. So for me, it's in the Nomad folder. So I'm going to do f:\nomad, and I'm just going to hit OK. And then I'm going to hit OK. Now go ahead and open up a terminal, and that can be something like PowerShell, or it could even be command prompt. I'll open up both here, and we're just going to type the command nomad. And assuming we applied the correct path to our path environment variable where nomad.exe lives, then this should work. So if you type nomad and you are not getting a list of the commands that you can run, then you have not added the nomad file's location to your path environment variable correctly. So now that Nomad is installed and we can run the Nomad command, the next step is to actually run the Nomad program. Now Nomad can run as a single node cluster on one computer or as a multi-node cluster on many computers that are all connected to each other. For the purposes of this video, we will be doing a one node cluster, and our node will be both our server and our client. And then later in the video, we will set up an additional Linux client to be used with our cluster. So go ahead and open up a terminal, preferably PowerShell, and you're going to want to go ahead and actually open this one as administrator. So right click, run as administrator. And you'll be dropped into the Windows System 32 path, and that's fine. If you don't have the permissions to do this, you probably shouldn't be doing this on that computer anyway. So we're going to start by running Nomad in dev mode. And so what I mean by that is we're going to run the command nomad agent, right? And you see how if I just run nomad agent, you must specify either server, client, or dev mode. Well, nomad agent is the command that we run to either turn a computer into a server or a client, or optionally dev mode, which makes it both. And now we're going to start with dev mode. So we're going to do -dev, and we're just going to pass an additional flag, -bind 0.0.0.0. And this actually allows us to launch the Nomad server. And by specifying a bind of all zeros, we're binding the Nomad server address to the host system IP address. So I'm just going to hit enter. And now you'll see that no configuration files were loaded, and that is going to become important, and we'll go over that. Now you see a whole bunch of stuff streaming here in the client. That's fine. Once you see node registration complete, what you want to do is you want to go ahead and you want to open some type of browser on your computer. And once your browser is open, you want to go ahead and go to localhost :4646. And because Nomad is running, that's going to bring you to the Nomad server. So if you want to look around, see what's going on in here with dev mode, that's great. Now, that works fine for getting Nomad up and running so you can look around. But the problem with -dev mode is that it won't stay persistent. If our computer restarts, right, we lose all the data that we created when running Nomad in dev mode. So I'll show you that. So if I go to variables real quick and I create a variable and I'll just call it whatever I want, test, 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 I'll save this variable. So if my Nomad cluster, my data was persistent, then I could stop Nomad, start it, and this would stay here, right? So I'm going to hit Control-C here in PowerShell, and that's going to stop my Nomad server. So if I refresh, the page is not going to be available. So then I'm going to go ahead and run that command again, nomad agent -dev, to bring my Nomad server back up. And now once it's up, you'll notice there are no more variables. And that is because when you're using -dev agent mode, your data is not persistent. It is only for testing and development purposes So I'm going to go ahead and stop Nomad in dev mode. I'm going to hit Control L to clear the screen. And now Nomad is no longer running. So now what we're going to do is we're going to register Nomad as a Windows service so that every time our computer restarts, Nomad starts with it. And to do that, we are going to start by creating a configuration file. So somewhere on your computer, probably in a folder called Nomad like I've done here, I have created a file called config.hcl. And HCL stands for HashiCorp Configuration Language because HashiCorp created Nomad. And in that file, we're just going to specify a few things. We're going to specify data_directory. And this is telling Nomad, the Nomad server, when it starts, where are we putting our data, right? So I have on my F drive a folder called Nomad. And so that's where I want to put all of my Nomad data. So you'll notice here, I have 2 backslashes. And this is a requirement when you are running Nomad on Windows. Now, really, this path, this location here, is F:\nomad, but we have to escape the slash with additional backslash because we're running on Windows. So make sure you do that when running Nomad on Windows. Otherwise, your Nomad server will not start. And then we're going to specify bind_address, ADDR. And this is, again, going to be equal to 4 zeros. And we have a client block and a server block. Now, normally, you would not specify a client and a server configuration on the same host, right? You would have your client nodes, your client servers, your client hosts, and you would have your server nodes, server PCs, right? And those would be separate configurations, different jobs for different folks. But for the purposes of this video, we are combining the two. So in the client block, we have enabled equals true, and that's just saying, hey, this computer, this Nomad agent, it's a client. And then again, server enabled equals true, just telling the Nomad agent, hey, you're a server. So we're telling the agent you are both a server and a client. And bootstrap_expect means that the Nomad cluster only expects one server in order to be considered healthy and start, because this is our only Nomad server in our cluster. So once you've got this config file built, and I will leave a link in the description to a GitHub repository that contains this file as well, you're going to want to go ahead and save it. Now, I am using Visual Studio Code to kind of have this config file open up here and a terminal open down here, right? So this is just PowerShell that you're looking at. Down here, I went to terminal, new terminal, right? And this is just PowerShell. So this is the equivalent of running PowerShell. Now, once you've got this config file created, we are going to go ahead and go back to PowerShell. And what we're going to do, making sure, again, that we are running as administrator, we're going to type sc.exe. And this is the way we create services within Windows. And we're going to type create. And then what is the name of our service? It's going to be Nomad. And then we have to provide the full path on our system as bin path equals quotation mark F:\nomad nomad.exe. So we have to provide the location to our Nomad binary on our computer. And then the command agent. And then we're going to pass a flag -config. And we have to provide the full path to our config. So I know that the config file over here that I just created is on my F drive, F:\/ in the Nomad folder, and it is called config.hcl. And then we're going to close those quotation marks. And again, I will leave a link to a GitHub repository with this command and these instructions in the description of the video. And then we're going to say start equals auto. And this is telling the Windows service create command that when we start this computer, automatically start this service. So we hit enter and we should see create service success. So now what we can do is we can run sc.exe start Nomad, and that should start our Nomad service. So I'm going to bring up my browser and I'm just going to refresh this page, and voila, Nomad is up. Now you'll see here I have some variables, and that's because I have some existing data in that data directory that we defined from earlier testing. But when you start Nomad, you won't see any of this here. You should just end up at this page that says no jobs. So congratulations if you've made it this far. You have successfully installed Nomad as a Windows service on Windows. Next, I'm going to go over the Linux install. So if you're not interested in that, go ahead and skip ahead through the chapters of the video where we're going to start actually deploying Minecraft on Nomad. If you are not interested in running Nomad on Windows, this is how you install and run it on Linux. So to begin, I have an Ubuntu machine running on Amazon Web Services, and I have remoted in using SSH. And on the right here, you'll notice HashiCorp has some very well thought out and specific instructions, although missing some pieces, and we'll walk through those, on how to download and install Nomad and get it running on Linux. So we're going to follow along with this for the most part. So just copying and pasting, we're going to start by creating an environment variable, and this is the version of Nomad that we want to install, and for this video I'm using 1.6.2. So I'll set that environment variable, and then I can go ahead and use curl to go ahead and download that version. And now I have a zip file. So now I'm going to go ahead and unzip that file, and that's going to create a file called Nomad. And this is the executable file, nomad.exe, that we saw on Windows. And so now what we're going to do is actually change the owner and group for the Nomad executable to root, because we're going to go ahead and move that into our path. So using this command sudo move nomad into user local bin. And now this is the same thing we did on Windows, where we opened up the environment variables and went to path, right? If I echo path, we can see that I have user local bin as a path within my path environment variable. So as long as I move Nomad into there, I can run Nomad from anywhere. So you'll see that I can now run the Nomad command, although it's not here in this directory. So then what we're going to do is optionally we can do these Nomad autocomplete commands. And this is actually going to, I already did it, but so that's why I get this error. This is going to turn on autocomplete for Nomad. And now we come to this command to create a data directory, and this is where all of our Nomad data is going to go. So we're going to make this directory, but there's an additional thing we need to do. And that is we have to change the ownership for the Nomad data directory, where all of our Nomad data is going to go, to be the owner and group Nomad. And now you'll see it says invalid user. And that is because we actually haven't created the Nomad user yet. So this next command, use sudo user add, right? We'll just copy that. And this is creating a system user account on this host called Nomad. So now I can make the Nomad account, the user, the owner and group for the opt/nomad directory. Now, not doing this will cause Nomad to fail when it attempts to start and write to the /opt/nomad directory. So the next thing they want us to do is configure a systemd service, and this is the equivalent of the Windows service that we created using sc.exe. Essentially, what this does for us is it allows us to stop and start Nomad at will, and also allows Nomad to restart automatically when the server restarts. So we're just going to copy this command, and that's going to create a nomad.service systemd file. And then we're going to go ahead and we're going to edit this file. And so I've gone ahead and copied and pasted that file from over here. And again, I'll include a link in the description of the video into here. Now, the most important part of this file, the one you really want to pay attention to, and the only one that's probably might change for you in this video if you choose to deviate, is this exec start line here. So this is the location of the Nomad binary, and earlier we moved it into user local bin. And then the -config flag, that points to the location of your Nomad configuration. Now, we have not created etc nomad.d yet, and so let's go ahead, and that should be the next step here. Yes, configure Nomad. So we're going to create a directory called etc nomad.d. And then there's a command here to change this directory ownership to just root for read, write, and execute. However, we're going to deviate from that. So when you get to this point where it says sudo chmod 700 etc nomad.d, instead of running that, what I want you to do is actually run sudo chown :nomad etc nomad.d. And then I want you to run sudo chmod 750 etc nomad.d. And what that's going to do for us, right? So if I do an ls-la etc grep nomad, that's going to go ahead and change the group ownership of the nomad.d directory to the nomad user. And it's also going to set the group permissions to read and execute. And again, we're doing that because if we don't, then Nomad isn't going to start. So all that's left for us is to create the configuration file. So we'll copy this command to create nomad.hcl, and then we'll go ahead and we'll edit that. And this is going to be the same config we used on Windows, so let me go get that real quick. And so on Windows, we specified the path to our Nomad data directory as the hard drive /nomad, but for us on Linux, it's just going to be opt nomad. And then we're going to leave the bind address as all zeros, which will bind the Nomad agent to expose the application on the default interface of this host. And then we have our client and server blocks. Now, we're telling this agent that you are a client, so we're enabling client, and you are a server, we're enabling server. Typically, in a real environment, you would have, your host would not be both a client and a server. You would have a couple servers and then a whole slew of clients, but normally they would never both be server and client. But for the purposes of this video, we're just making this one host, both a server and a client. And then bootstrap expect is just how many servers do you expect to come up and be healthy before we can consider this Nomad cluster healthy. And because we only have one, we're just doing the one. So we'll save that. And now, according to our documentation over here, we can go ahead and run systemctl enable nomad. And all that does is tell systemd to make sure the Nomad service starts automatically when the server starts. And then we can start Nomad. And then we can check the status of the Nomad service. And it says running. And here it says node registration complete. Now what I should be able to do is just head on over to the IP address of my server on Amazon Web Services. So 44. Oh, it's already right there. And port 4646. And Nomad is running. And let's do a test. Make sure our storage is persistent. So let's just create a variable real quick. Save variable. And then let's come over here and let's actually stop the Nomad service. So now this should be dead. And it is. And then let's go ahead and start it again. And it'll come back, and yes, our data has persisted, our variable is still here. And if you want to take a look at what's going on inside the data directory, if you head on over to /opt and cd into nomad, you can see that some additional things have been created that we did not create. And that is the data that goes into the data directory. So congratulations, you have now installed and you are running Nomad on Linux. So whether you installed Nomad on Windows or Linux, so here I have the Windows version that I installed, and here I have the Linux version that we installed. The majority of this video is going to be the same between the two. However, there are a few differences that will come up, and we will go over them as they come up. So when you first get into Nomad, you probably have no idea what any of this stuff is. But the first place you're brought is jobs. And what are jobs in Nomad? Well, according to the documentation of Nomad, a job is a specification provided by a user that declares a workload for Nomad, where you describe the desired state, expressing that the job should be running, but not where it should be run, right? The responsibility of Nomad to ensure that the state matches your desired state. Okay, what does that really mean? Well, it means that you, as the user, you compose a file called a job file. And that job file, right? So if you hit run job, you can define a job definition. And that definition tells Nomad, here is what I would like to run in what configuration, and make sure it's running that way at all times. And then Nomad takes it and it puts it somewhere, usually on a client in the cluster. And we'll go over that in a minute, and that is how we're going to actually run Minecraft as a job. If you come over here to clients and servers, you will see that the name of my client, desktop FOM FFV3, and the name of my server is the same because we have installed the client and server on the same host, which again, normally you wouldn't do in a real production environment, but for the purposes of this video, that's what we're doing. So if you come to client, you'll see a list of your clients, and by default, everything goes in data center DC1. And we click on a client, we can see some information about the client, how much memory, CPU, some events, right? And then there's this thing called driver status. Now we'll go over what drivers are in a minute, but just note that this is important. And if you want to see what drivers are available on a client, you would just click on clients and then click on that particular client. And then some more information. And so here on the Linux Nomad, if I go to clients, click on client, you'll see that, it looks pretty much the same. Just for some reason on the Linux host, there are no drivers detected, while on the Windows host, there is a Java driver detected. So in order to start running Minecraft on Nomad, we first have to create a job. So under jobs on the left, we're going to hit run job on the right. And this will bring you to the job definition. And this is where we define a job definition. So I can start typing whatever I want here to define my job. Optionally, I could upload a file or choose from a template. If you hit choose from template, you'll see hello world and a few others here. But I've gone ahead and already created a few templates here. Now you'll see I have Minecraft raw exec twice. We'll go over that in a minute. Minecraft Docker and Minecraft Java. Why do I have all these different Minecraft templates? Well, good question. So if I take a look at one, right? Minecraft Java. There's a block here called driver equals Java. And then again, if I go to Minecraft Docker, driver equals Docker. And then as you would assume, raw exec, driver equals raw exec. So what is a driver in Nomad? Well, when you define a job in Nomad, you define tasks. And for each task, you have to define a task driver. And a task driver is used by the Nomad client to execute the task, right? If you want to run a script, right? So actually, let's go to clients and go ahead and take a look at your client. You'll see driver status and the available drivers if they've been detected or not. So when you install Nomad, Nomad can detect, if you have Docker installed, and that way you can then start using the Docker task driver for some of your tasks. And you can see that on this client, Java is installed, and Nomad is detecting that Java is installed. So I can use the Java task driver. So a task driver is how you tell Nomad how it's going to execute a task. If you want to launch a Docker container in one of your tasks, you're probably going to use the Docker task driver. If you're going to launch a Java application like Minecraft, you're probably going to use the Java task driver, but optionally, you could use exec or raw exec to run a script that runs the Java command to launch Minecraft. So that was what a task driver is. So back to jobs, run job. I'll choose from template, and I'm going to choose good Minecraft raw exec. So don't worry about pausing the video and trying to type all this out. I will have a link in the description to a GitHub repository that has this file, so you can just go ahead and copy paste, and then we'll walk through what's going on in this file. So now that you have copied and pasted this job file into the job definition, this template creates the eula.txt file, downloads Minecraft server.jar, and uses PowerShell to execute Java and start Minecraft. So you don't have to start Minecraft this way. I'm just showing you different examples of how you could start Minecraft with Nomad. So a job definition always starts with a job block, obviously, and then the name of your job. And then data centers is a list of data centers that this job belongs to. Now, when you install Nomad, if you don't define a data center in your config file, everything just goes in DC1. So we're just defining DC1. If you followed along with the install of this video, then you're going to also define DC1 here. And then we have a group block, and a group block defines a series of tasks that should be co-located on the same Nomad client. So then what is a task? Well, a task is an individual unit of work within Nomad. So say we had to do 3 different things, right? That would probably be 3 different tasks, right? So here I have 2 tasks, create eula.txt and start Minecraft. So I'm doing 2 things in one task, but then I have a second task that when Minecraft stops, we're going to use PowerShell to just close every application, close every Java process. So by defining both of these tasks in the same group block, I'm ensuring that when these tasks get assigned to a Nomad client in the cluster, they're both run on the same client. Otherwise, if they didn't belong to the same group, then Nomad might try to put this task on a client, and that just wouldn't make any sense, because why would you put the exit Minecraft task on a different client than where Minecraft is running? So let's go over this first task, EULA and start Minecraft. So I've defined a template block, and the template block instantiates an instance of a template renderer. So if you're familiar with something like Jinja templating, right? That's kind of what this is. So I've defined data. So this is the data that's going to go inside of the file that I'm going to create, and then the destination to put that data into. And that's going to go in local. And because I'm on Windows, careful here. If you're on Linux, it'll be 1/, but I'm on Windows, so I have to escape this first slash with an additional \. And then eula.txt. So that will create, if you're familiar with how Minecraft works and starting it, the eula.txt file that says I agree to the eula, because if we don't have that present when Minecraft starts, Minecraft won't start. And then within this task, I also define an artifact block. And the artifact block instructs Nomad to go ahead and fetch something and unpack it. Like maybe it's a file, a tarball, a binary. So for us, we're reaching out to the internet and we're grabbing Minecraft server.jar. And then we're defining where we want to put it. And again, on Windows, it's \/ local. But if you're following on Linux, you just want to go ahead and delete the backslashes and put a / in. And what we're going to do for this task is we're going to use the raw exec driver. Now, for every driver, you have to have a config block. And for every driver, the config block has different arguments that you can pass. Obviously, if you're using the Java driver, you're not going to have the same parameters and arguments as you would if you're using the Docker driver, right? So real quick, let's talk about the raw exec driver. If I'm trying to use this, I need to make sure that, let me just open a new tab here. I need to make sure that the client, one of my clients, has the raw exec driver detected. And we can see that my client does not have the raw exec driver detected. And that is because the raw exec driver is disabled in Nomad for security purposes by default. And it's used to execute any command or task you want on your system without any isolation. And so in their wisdom, rightfully so, HashiCorp has decided that you should only use raw exec with extreme care and disabled it by default. So how do we enable the raw exec driver? And then why am I not using the exec driver? Well, on Windows, you cannot use the exec driver. You can only use the raw exec driver. Now you can use Docker and Java on Windows. You just can't use exec on Windows, unfortunately. So this is my Windows client. So in order to enable the raw exec driver, I'm going to go ahead and edit my Nomad configuration file that we created when we installed Nomad. So here's my config.hcl that on Windows we had created as our Nomad configuration file. And in that file, we're going to put a plugin raw exec block. And I've included a link next to it. And again, I'm going to have all this in the link in the description to a GitHub repository. And then we specify the config for this plugin enabled true. So once you've added that to your configuration file, on Windows, we can just go ahead and run sc.exe stop nomad, and we'll let it stop. We'll give it a few seconds here. It's stopped, and then we're going to start it again. So it started, and now on my Windows client, we can see that the raw exec driver has been detected and is healthy. So now back to that job we were just going over. So my driver has been enabled on my client, so I can start using it. So what command do I want to run, right? So when you're using raw exec or exec, generally you're using it to run some kind of script, right? I'm going to run PowerShell because this client is on a Windows machine. If this were Linux, it would probably be Bash. But then if you're familiar with PowerShell, we do the dash command argument and then comma the command that I want to run. So we're going to cd change directory into local and then semicolon because we're going to do another command. So this is the equivalent if you're on Linux. This is the PowerShell's equivalent of doing this, right? We're going to run Java -jar and pass in server.jar no GUI, and that's going to start Minecraft. And then for each task, we can specify a resource block, and this just describes the requirements needed to execute the task. And then I've configured a second task called exit Minecraft, and there's a lifecycle hook here. So the lifecycle block allows us to specify when a task runs. So you specify hook equals, and this can be like pre-start or post-stop, and there's another one, but essentially because I've specified post-stop, this means after the main task, which is this one right here, finishes running. So if Minecraft exits, then go ahead and use the raw exec driver to run PowerShell to stop any process named Java and force it. And I'm doing this because sometimes Minecraft has an issue and it stops working, but the actual Java process does not stop. And therefore, Nomad cannot start another one to replace it because it's already running. So if Minecraft has a problem and Nomad needs to stop this job and start a new one to start a new Minecraft server in its place, it's going to run this command first in order to remove the Java process, so that it can then redeploy a healthy Minecraft in its place. Now, one other caveat I want to go over when using the raw exec driver. So I'm using it in this example to show you the different kinds of task drivers you can use to accomplish the same thing. But raw exec is actually pretty crappy, and I wouldn't recommend using it for most things, especially a persistent, long-lived application like Minecraft, where you've got data that you want to keep around long term, right? And that is because the raw exec driver does not support volume mounting. So what do I mean by that? Well, in Nomad, when we create a client, we can specify some place to put storage files that when data gets created, it gets put in that location. And then we can mount our tasks to, so let me actually just choose a template. So I have a template here called bad Minecraft. Raw exec. Hey, 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 no chewing on the wall. And I call it bad because it specifies some volume mounts. So within Nomad, when we create a client, in the config file, we can specify a volume mount. We're going to do this later, but essentially it tells Nomad this location on this host is where you can put data, and it's going to live there. And then for each task, we can mount the task to that volume. So for Minecraft, right, I could make sure that all my Minecraft data gets put onto the client into the data directory, and that way I never lose data. So back to the good raw exec example, I don't define any volume mounts in here because the raw exec driver does not support volume mounting. So when you use the raw exec driver, you can't persistently mount data anywhere. So then what is this local directory that I keep specifying throughout this file, right? I'm telling this task to create a file in the local directory. I'm telling this task, I'm telling it to download the server.jar and put it in this directory. So then if there's no persistent data, where is this local directory, right? Good question. So what Nomad actually does when we run this job, we'll see this. For each task, it creates, so here's my Nomad directory, right? So what happens is what Nomad does is for each task, within your Nomad data directory, so on Windows, I specified this as my F drive Nomad folder, there's this alloc, short for allocation, directory that gets created. And when you run a task, it creates a file system in here. And one of those directories that gets created is local. And that's where we're putting the template and the artifact that we download for that task. So HashiCorp actually has some pretty decent documentation about this file system for running tasks. So here's that alloc folder, and we create a folder for each task, and then there's this shared set of directories which contains like our logs and stuff for all of the tasks, right? But for each task, we get our own directory structure. So task 1, task 2, they each get local, private, secrets, temp, what have you. So the alloc directory is shared across all the tasks, right? So task 1 can put some data over here, and then task 2 can then go ahead and access it. But what would happen is if my task 1 was to create the EULA, and then I put it in local, and then task 2 was to run Minecraft, well, task 2 has a completely different local directory than task 1. So when Minecraft runs out of local directory for task 2, eula.txt will not exist in local directory. It'll exist in task 1's local directory. And so that is kind of why I am putting the EULA and server.jar all in the same task local directory and executing, and then changing directory into local for task 1 and executing Minecraft from there. So with all that information out of the way, go ahead and click the link in the description to the GitHub repository, copy the file for the raw exec task if you want, and then just go ahead and hit plan. And as long as the client is healthy, as long as you've enabled that raw exec driver on Windows, then all this should be green, and it should say all tasks successfully allocated, meaning Nomad has decided which client to put all of these on, and we can go ahead and hit run. Now you'll see a bunch of stuff up here, some stuff's going on. We can see that we're downloading the Minecraft artifact. And actually, let me switch over to the desktop. So you can see now that in that allocation folder, a new weird named folder has been created, right? And here's the task that's being run to create the EULA and start Minecraft. Oh, and here's the local directory. Right, here's my server.jar, my EULA.txt. So everything should work perfectly as long as Minecraft isn't already running on your client. And you can click into each task here. Now notice I have 2 tasks because my job definition has 2 tasks, but this one's never going to run unless there's a major error with this one. So I can click into the task that creates my EULA and starts Minecraft, and that'll give me more information about that specific task. I can view the logs, so I can see the Minecraft server instantiating itself. I can see all those files that I just showed you, right? And if we go to jobs, we see our job and the status is running. And so now what I should be able to do, because this is running on localhost, is I should be able to start Minecraft and connect. So let's go back to my desktop here, and I'm going to start Minecraft. And you want to make sure you're using the same Minecraft client version as the server you're running. So real quick, if you just go to that job you ran, if you're not sure which version of the server you downloaded and ran, you can go to logs, and you can actually see it in the logs. So starting version 1.20.1. So if you also are copying and pasting the file that I'm providing you in the GitHub repository, that will be 1.20.1. So make sure 1.20.1 is selected and hit play. And we're going to go to multiplayer. And I've already set it up here. Let me just delete it again. We're going to add a server, and I'm going to call it Nomad. And this is going to be on localhost :25565 because that is the default port for Minecraft. Now, if you're running Minecraft on a different server than the same server that you're connecting on, right? So I'm running my Nomad client on this computer that I'm also running the Minecraft client on. So I'm just going to put localhost, but you would put the IP address if that wasn't your case. And then I'm going to hit done, and then I should be able to connect. And we're in. We are into our Minecraft server running on Nomad using the raw exec driver. Let me just grab something real quick. Oh, that didn't give me anything. I need a block here and put something in my inventory. There we go. So now remember, I keep reiterating this over and over and over that the raw exec driver is not good for persistent data. So I'm going to actually disconnect and close that. And I'm going to come over to my job, and I'm going to open Task Manager, and I'm actually going to look for Minecraft. Where is it? Java. This is Minecraft, right? And I'm going to end task. And you can see that Nomad just realized that Minecraft took a crap. It's not working anymore. So what Nomad is going to do, Nomad says, hey, the way you wanted this application or job to be running is no longer how it is running. Let me go ahead and rerun it, try and get it back up and healthy. So there we go. Nomad went ahead and reran this task here. So this is actually one of the main benefits of using an application orchestrator and scheduler, is that because you've described how you want a workload to be run, and Nomad is constantly ensuring it's being run that way, right? You don't have to, if Minecraft takes a crap, you don't have to log in and restart it yourself. Nomad takes care of that. Make sure it's running at all times the way you want it to be running. So notice when I log back in, I still have this block in my inventory that I had initially, even though Nomad restarted the Minecraft task, right? But before I told you that data wasn't persistent, so I wasn't lying to you, right? So let me disconnect here. So it kind of is persistent in a way. It's not persistent in an ideal way that ensures that you're going to be able to keep your data as long as you want. So here's that allocation task directory that I got created, right? So here is where, in the world directory, typical of every Minecraft server, is where all my Minecraft data is at. So I'm going to go ahead and stop the Minecraft job. And I'm actually going to go ahead and purge it. Now notice when I purge it, this directory, it sticks around. So again, my data's sticking around. So I purged that job, it no longer exists, but we can see that this folder over here is still hanging around, right? Our Minecraft data is still persistent. So at this point, I am lying to you. But what I want to show you, and let me switch over here. Nomad comes with what's called the garbage collection. So Nomad periodically garbage collects jobs, evaluations, allocations, and nodes. So when Nomad at specific intervals doesn't need stuff anymore, it gets rid of it to free up space and resources. Nomad only permanently deletes objects once they are terminal and no longer needed for future scheduling decisions. So I just had a job that created that folder and that Minecraft data, and I got rid of it. I purged it. So at some point, the Nomad garbage collection will run through. The garbage men will come down the block and clean up all my Minecraft data. Therefore, and then I will lose it forever. And we can see, if we go to this link, we can actually modify these intervals, right? So for instance, node garbage collection threshold by default, if a node in our Nomad cluster dies, after 24 hours, it's just going to be removed by the garbage man. And then similarly, we have these defaults set for job garbage collection. So because we're using these defaults and we have not specified, because we're using these defaults and we have not modified our Nomad configuration to increase them, at some point, that folder with our Minecraft data will disappear and be deleted, and that is not desired. So that is why I am telling you that the raw exec driver, because it does not support volume mounts, is not a viable option for persistent long-lived application data. Now, one thing I want to make clear here is if you hit stop job, right? Yes, stop job. That does not, like over here, that does not stop Minecraft. So this Java process, this is Minecraft, right? So Nomad is no longer ensuring that it's no longer running the job to keep Minecraft running, but Minecraft is still running. And that's really something we want to be aware of is, what happens if our job stop? That doesn't necessarily mean our application stops. Right? So then what happens is if I restart this job, right, you're going to see that Minecraft is going to fail twice. And then what's going to happen is the exit Minecraft task is actually going to run the third time. So let me refresh this. If we look at the logs, Minecraft is going to say something along those lines of there was an exception, address is already in use, bind, and that means because the Minecraft server is already running, Minecraft can't start. So it's going to try to start a few times, twice. And then we notice there's no logs for the exit Minecraft. And the exit Minecraft task, if we look at the definition, is to run post stop. So eventually, when this task fails twice, then the third time this task is going to run, and it's going to use PowerShell to stop the Java process. And we can see it just stopped over here. And the fourth time, then Minecraft will start up. So now, after doing that post stop task to exit the Java process, Minecraft is back up and running again, and we have one allocation healthy. We can see that Minecraft is indeed started again, and that's indicative of this output right here. And now notice when we view the logs for exit Minecraft on the recent allocation, the one that's actually running Minecraft, this task hasn't run, obviously. But if we look at the one below it, that is when it ran. So if we look at this task, right, Minecraft tried to run a few times. It couldn't run. It failed. Then the next allocation actually ran the task to exit the Java process. And I know it says it can't find it, but it did find it and close it. Otherwise, this wouldn't have worked. And then the next one starts up Minecraft. So moving on from the raw exec task driver, next we're moving on to the Java task driver. So unlike the raw exec task driver, where we provided the path to like a script or something that we could execute, and in our case, we specifically just used PowerShell to call the Java command. Now we're just going to use the Java driver and provide our Java arguments and the path to our server.jar. So I've killed the raw exec from the last example, and now I'm going to go over the Minecraft Java template. So I'm going to choose that and I'm going to hit apply. And similar to the raw exec task, we specify our job, our data center, DC1, and our group. And again, the group just means if I have multiple tasks, they will all be assigned to the same client and executed it on that client. So we have one task in this job, and that is Java Minecraft. So just like we did in the raw exec job, we're using the artifact block, but here we're using it twice. So we're using it once to download eula.txt from my GitHub repo that I'm using, and there's a link in the description. And this is what it looks like. This is it. This is the raw file out on GitHub. And I'm doing this to show you that there are different ways to do different things, right? Maybe get a little creative. You know, before in the raw exec job, we used the template block to template eula.txt. Now we're using the artifact block to download it. And then we specify mode file because if we don't, a directory named eula.txt will be created and the file will be put in there, and that's not what we want. So then we call the artifact block again. This time we're just specifying the source to the Minecraft server.jar file, and we're not specifying a destination for that like we did in the raw exec job example, but that's going into the local directory for our allocation. Then we come to our Java driver, and of course the most important part of this, you want to make sure if you go to clients here on the left, go ahead and look at your client. Make sure that you have a client that says healthy for the Java driver. And then if you scroll down for the Java driver, you can see some more information about it. Now you want to make sure that specifically for Minecraft that you are using Java JDK 17, and I'll put a link in the description and in the GitHub repository. But if you're not using this, you're going to get an error, and it's going to say something along the lines of exception in thread. Main has been compiled by a more recent version of a Java runtime. Now, if for whatever reason your driver status for Java is not detected or unhealthy, what you want to do is you want to head over to the documentation. I'll put a link in the description, but the client attributes for the Java driver are specified here. So essentially, Nomad determines if Java is healthy by running java-version. So you could do that too if you open up PowerShell and just run java-version. And as long as that returns Java version 17, you will be good to go, or you should be. So back in our Java job template, right, we have a configuration block for the Java driver, and we're specifying the jar path, and this is the location to the server.jar that we just downloaded. And because we downloaded it with the artifact block and did not specify a destination or where to put it, it went into local. So we're specifying local // And again, on Windows, you must escape backslashes with an additional backslash. That is a requirement on Windows. Then we can pass in some JVM options and additionally some args. And then finally, we have our resources block, which tries to limit or set the amount of resources that this task can and will use. So with a handful of information, we're going to hit plan. And as long as your client is healthy and has Java installed and the Java task driver is correctly configured, we can hit run. Now you'll notice mine's had a bunch of exit stuff here. That was from earlier testing, but yours will be blank. You won't have anything. And so we'll see that a task was received. We're building a task directory. The client is downloading our artifacts, our eula.txt and minecraft-server.jar. And it's done. So we can see our recent allocation, right? Here's our task group, Minecraft Server Java, and it's running. We can see the recent allocation is running for the Java Minecraft task. And let's take a look at the logs. And we can see that Minecraft is successfully running. If we click into this task, we can see some more information. Importantly, we can click Files, and we can see that here's local, and this is where our server.jar went. And if we go back, here's the eula.txt that we created. It got put in this root directory for the task, and here's all the Minecraft files. And then if we come to our data directory on our client machine, which is my Windows PC because it is both my client and my server, you'll see a folder here that got created. And this one is for the Java Minecraft. So I'll click into it and we can see that same file structure that we see over here on my client. So I can go to Java Minecraft and this is where this file system got built. Now, just like the raw exec task driver, the Java task driver on Windows does not support volume mounting. So if we look at the capabilities for the Java driver, right, volume mounting is none or all only for Linux, right? So all this data over here, this temporary file system that got created by Nomad, it'll stick around as long as our job remains healthy. But if for whatever reason our job stops for long enough, the garbage man, the garbage collector that's in Nomad will come around and delete all of this data, thus deleting your Minecraft world data. So with Minecraft running using the Java task driver, I've loaded up the client. I'll go ahead and hit play. Again, you're going to want to make sure that your client version that you're choosing, which here is 1.20.1, matches your Minecraft server version that you're using. And you can also view that in the logs. If you scroll up, it'll say starting Minecraft server version 1.20.1. Now, if you're following along with this video and you're using the job definition that I'm putting in GitHub, this link here will pull down 1.20.1 of the Minecraft server. So Minecraft's up. Let's go ahead and just connect on localhost :25565, and we are in to our Minecraft world. So at this point, I've gone over two different task drivers, how to run Minecraft two different ways on Windows. First with the raw exec task driver, but we can't use it for stateful workloads because we can't do any volume mounting with the raw exec task driver. And second, we looked at the Java task driver, which does do volume mounting, but not on Windows, only on Linux. So we can't run any stateful workloads like Minecraft, where we want all of our data to remain forever on Windows using either of these two task drivers. So then we have to find something that can allow us to run stateful workloads and that data to persist. And that would be something like the Docker task driver, which allows volume mounting on both Windows and Linux, or the Java task driver that allows mounting on Linux, or we could use the exec or isolated fork task driver, which allows mounting on Windows and Linux. Now, the only reason we didn't use this for Windows was because, ironically, it's not supported on Windows. So it really doesn't support it on Windows. So since we just got done running this Minecraft job on Windows using the Java task driver, let's go ahead and rerun this same thing with the Java task driver, but now we're going to do it on Linux. So at the beginning of the video, I showed you how to install Nomad on Windows, which is this Nomad here, but then I also showed you how to install it on Linux, which is this Nomad here. So this Nomad application right here running at a different IP address than this one is the one that I have running on Linux. And just like the Windows one is both a client and a server. So if I look at clients, it's the client and it's the server. And then if I scroll down to driver status for this Linux client, I can see that I have no healthy available drivers. So to begin, if I want to start using the Java task driver on Linux with Nomad, I need to install Java. So I'm running on an Ubuntu Linux machine running on Amazon Web Services, and this is both my Nomad server and client. So we can see that the Nomad service is running. If you're interested on how to install this on Linux, go ahead and look at the beginning of the video. There should be a section or chapter on how to do that. And now because I'm on Ubuntu, I have the benefit of being able to use the package manager to install OpenJDK 17 and OpenJDK 17JRE. Now this is required in order to run Minecraft. So I'm going to go ahead and run this, and I'm just going to install Java real quick. So now if I run java-version, after that's installed, I should get back OpenJDK 17. So once you make that change and you go back into Nomad and you look at your clients, you're going to see that the Java driver is still not detected. And this is because of the way that we are running Nomad, and we need to fix this. Now on the documentation for the Java task driver, they clearly tell us the client requirements and that Java requires Java to be installed, which we did in your system's path, and it is on Linux. Nomad must run as root, since it will use chroot and C groups, which require root privileges. So what does that mean to us, the people who don't know what that means? Well, it means that file we created, the systemd service, when we started Nomad, we need to go ahead and edit that. So what we're going to do is we're going to, first off, I'm going to become root. That's going to make this a whole lot easier. And we're going to go ahead and we're going to edit this file nomad.service that we created when we installed and created the Nomad service. And this is at etc systemd system nomad.service. So what we're going to do is we're going to go ahead and modify the user to be root, but we're going to leave group nomad. And we're going to save that file. And then once we've edited that file, we can do a systemctl restart nomad, and that's going to restart our Nomad service. But it's telling us that because we've changed the configuration file, we need to run a daemon reload. So we'll do systemctl daemon reload, and then we can do restart nomad. So now that we've gone ahead and done that, notice that when I go back to my client on my Linux Nomad application, not only is my Java driver detected and healthy, but now my exec driver is detected and healthy. All right, so now that the Linux Nomad client is healthy with the Java task driver enabled, we're going to go ahead and we're going to run our Minecraft job on Linux. So what we're going to do is we're going to go ahead and we're going to hit run job. And on my Linux machine, I don't have that template, so I'm going to get it from my Windows Nomad. So what I'm going to do is I'm going to go to jobs, I'm going to hit run job, I'm going to hit choose from template, and then I'm going to hit manage. And then I'm going to go to my Minecraft Java, and I'm going to copy this. And for you, there will be a link in the description to a GitHub repository that contains this file. So all you have to do is go there and copy paste the one that's for Linux. And I'll have like a folder in there, one for Windows, one for Linux. And then I'll come over to the Linux Nomad, and I'll hit create new template, and I'll call it Minecraft Java, and I will paste that in there. Now real quick, because I'm copying this from Windows, but you won't have to, you'll be copying it from a repository, it'll already be edited for Linux. I can keep all this the same. The only things I need to change are here, local, right? I need to change this from a Windows double backslash to just a / because now I'm on Linux, not Windows. And then I'll save that. Cannot be saved. Oh, I got an error. This cannot have a space in it. Put a dash, and we'll hit save. All right, so that template is saved. So I'll go ahead and choose Minecraft Java, apply. This will be allocated to this client because the Java task driver is enabled. I'll hit run, and we'll see if Minecraft comes up. Now, if for whatever reason your allocation keeps stopping, during the preparing spawn area stage, right, you'll also see this failed to load properties file. Ignore that as long as it gets past that and you start seeing preparing spawn area, right? If it keeps stopping in the middle of that, what you want to do is you want to come up here to definition for your job and you want to hit edit. And then you want to go ahead and bump up your CPU, your memory, your disk, right? And see if it gets a little farther and just keep bumping it up. So I'm going to bump mine up now. I'm going to do 4,000 and 4,000. And I'll bump disk up to 8. I'm going to go ahead and hit plan. And then we're going to see if we get a little bit further. So after bumping up those resources in my definition, I can see that my spawn area is done preparing. So Minecraft should be running now. Now, because I have my Linux machine running out on Amazon Web Services, I have a public IP address assigned to it so that I can access it from my house. Now, this is different from the Windows PC where it was running on my local system, localhost. So with that in mind, I've loaded up the Minecraft client, again, making sure my client version matches my server version. I'll hit play. We'll go to multiplayer. And I'll go ahead and edit the Nomad server. And we're still going to access it on port 25565, but now it's going to be the IP address of my Linux machine. And here we go. We've logged in. So now Minecraft is running on my Linux Nomad client out on Amazon Web Services, but we still have the same issue that we had on Windows in which our data isn't persistent, right? As soon as our Minecraft job stops for long enough, the garbage collector is going to come through and clean up all of our data. And that data is stored in my Nomad data directory that I specified in my Nomad configuration file, right? Specifically in the alloc directory. So if I go in there, all the jobs I've run, right, here's all of them, even the ones that I've purged, right? These are all temporary folders, but my Minecraft data sits in one of these. So right now, my Minecraft job that's running, my current Minecraft server is running in this allocation folder E615, all that stuff, right? So this is where my Minecraft data is sitting. It's sitting in this Java Minecraft folder. So if something happens to Minecraft, after the garbage collector comes through and gets rid of all these folders because they're no longer needed, I'm going to lose all my Minecraft data. But we can solve this on Linux with the Java task driver using volume mounts. And let's start getting into persistent data. Now, there are a few different ways we can do volume mounts within Nomad, but for the purposes of this video, we're going to focus on something called host volumes. So in order to do this, first we need to pick a client. And if you're following along with this video, our only client is the Linux server and client that Nomad is running on. And we created this configuration file. So within our configuration file, we have this client stanza or block. And then within here, we're going to need to add a host volume block. So host underscore volume, and then we need to name the volume. So we're going to name it Minecraft. And this is very important. Please make sure that you take note of this name. And then the path. So on this machine, where would you like this volume to be basically mounted? So when you put data onto this volume, where is it going to go? So for us, we're going to do opt Minecraft. I'm going to create a directory called Minecraft, and then read only false. We're going to keep this false because we want Minecraft to be able to write. And basically what we're going to do here is we're going to tell our Nomad task that runs Minecraft to mount the Minecraft/world directory to this path on our client. And that's going to make sure that our data persists if our Nomad task dies or goes away for a long period of time. So with this in here, I'm going to save this file. So now with those changes in the configuration file, I can go ahead and create that opt Minecraft directory that I specified as my path for my volume. And then I can go ahead and restart Nomad. So systemctl restart Nomad, and that will pick up the changes in the configuration file. So now back here in Nomad, now that it's back up, come over here to clients and click on that client that we just configured. And now you'll see host volumes, and you'll see the name of the volume we just configured. So this name correlates to that host underscore volume that you configured. Source is the path, and then whether it's read or write or both. So what we're going to do is we're going to say when the Minecraft task runs, go ahead and mount a certain directory into opt/Minecraft, and that's where we're going to write and read data from. So we're essentially going to say mount world into opt Minecraft. So let's go ahead and do that. So with that volume now configured on our client, let's go ahead and go up to jobs, and I'll hit run job, and I'm going to choose from template. Now I've modified Minecraft Java to include the volume stanza in the group stanza and the volume mount stanza block within the task stanza block. So I'll leave a link in the description to the GitHub repository. Again, I've sent this over and over. There's going to be a link in the description to a GitHub repository that's going to be organized in a way to where you can access all these different templates. And there's going to be one in there for the volume mounting stuff with Java. Now, under group, we have to specify the volume that exists on the cluster that we would like to access. So if we were to go ahead and look at our client again, look at my client. All right, this is my host volume. So this is what I need to specify for the volume name and the source. Not so much the volume name, but it helps if they just match, right? Make everything simple. But the source definitely needs to match. So we're saying, let's get that host volume, type host, volume name, Minecraft. And then the task, what it can do is it can mount that volume. So which volume do I want to mount? Well, I want to mount the Minecraft volume that I just accessed from the cluster. And then we specify a destination. So within this task, what directory do you want to mount into that volume? And we're going to mount /world because that's where all the Minecraft data goes. Now /world doesn't exist yet, but when we start Minecraft, it's going to go ahead and create a /world directory and put a bunch of data in there. And that's the data we want to go into opt/Minecraft on our host. And we're keeping the jar path as local because when the task runs and it creates the task working directory, it's going to download server.jar into local, and then we're just going to execute it from there. And then I bumped up the resources in this template in order to allow Minecraft to actually run on my Linux machine. So I'm going to hit plan and run, and I'm going to let that go. So I'm going to come over to opt Minecraft, and we can see that this directory is empty, but it should start filling up once Minecraft starts with all the data that would get put into /world. And there we go. We can see that now this directory is starting to fill up with some data. So we get data, player data, region, all this good stuff, right? And then we'll come back to Nomad, and we can see Minecraft is running. It's healthy. Let's view the logs. And we're preparing spawn area. So once this is done, I'll go ahead and launch the client, and we'll connect. So my Minecraft server is up and running. Again, making sure my client version matches my server version. I'm going to hit play, and we're going to go in. And what we're going to do is we're going to put something in our inventory. And then we're going to destroy the Nomad job, purge it, and then we're going to rerun Nomad, which should connect to our existing data. And so when I log back in, I should have whatever block was in my inventory, and thus successfully testing our persistent data. I'm going to go to multiplayer. I'm going to connect to Nomad running out on Amazon Web Services. All right, so I'm going to put something in my inventory. I'll just do 2 blocks, right? So with that, that means I should be able to disconnect from Minecraft. I should be able to then come over here to my job, stop it, purge it. Now, Nomad is no longer running. The Minecraft server has been deleted. But then back here in opt/data, you'll see all of my data still exists. It's still just sitting here on my system, and nothing's going to come through and clean this up if I don't want it to, right? So it's persistent. So I should be able to hit run job, and again, I'll choose the same template. We'll do a plan, run, and then when Minecraft starts again, I should be able to log in, and I should have those 2 sand blocks in my inventory still. So Minecraft's up, it prepared the spawn area. Now notice it happened a lot quicker this time. There's a reason for that, because our data persisted. So then I'll try to log in again, and I'm in, and you'll notice my 2 sand blocks are still here in my inventory. So we've successfully tested that our data for our Minecraft world is persistent. And then so finally we come to using the Docker task driver with Nomad to run Minecraft as a container. So we're doing this one on Linux. Specifically, I am on Ubuntu, and you'll see here on the right, I have the instructions from Docker on how to install Docker on Ubuntu. So I'm just gonna follow through these real quick. There will be a link in the description to these if you would like to follow along. So we're just gonna copy this command for step 1, and that is to set up the Docker apt repository. Then we're gonna come down here to step 2, and we're gonna actually install the Docker packages. So again, we just copy and paste. So apt install docker ce, and Docker is installed. So I'm going to clear the screen, and I'm going to run a docker ps just to make sure it's running, and it is. So I'll exit, and now I'm running as just a user, and I'm not in the Docker group, so I can't run it from there. So back to root I go. So Docker's installed. That was quick. That was easy. Now let's get to the Nomad part. So I shouldn't have to restart Nomad or anything. I have no jobs running. I'm going to go to that client where I just installed Docker. Here's that client. I'm going to take a look at it, and under driver status, we can now see that Docker is indeed detected and healthy as of 2 minutes ago. So that's something to take note of. Every Nomad client that you would like to use Docker on must have Docker installed on that client. So to get started running Minecraft, I'm going to go ahead and create my job. So I'm going to go to run job, and I'm going to create a template. I'm going to hit choose from template and then go to create new template. And I'm going to call it Docker-Minecraft. And now I'm going to paste the template in here, and I'll leave a link in the description to the GitHub repository that contains this template so you can paste it too. But if you've been following along, we've been going over most of these stanzas, these blocks here, and what they mean. So real quick, just to recap, when we're running it with Docker, most of this stays the same. We just differ a little because now we're using Docker in containers. So for our group, right, we're going to define count. And we have not defined count up until this point in any other job definition, but you still can. It's not unique to Docker. But what it really means is how many instances of our application should we be running? And if we don't include this, it'll just default to 1 anyway. And then also in the group block, we have a network stanza with 2 port stanzas that define static ports that we should be using in this group. And then we define the networking mode, and that will be bridge. And just like we did in the Java job definition when we used volume mounts, we went ahead and we configured our host. So let's go take a look at that. Our client is configured with the host volume. So I'm using the same one that we used when we demonstrated this with the Java task driver on Linux using volume mounts. So we're going to take this volume Minecraft, and we're going to mount all of our world data into opt/Minecraft on this client. So if I go to opt/Minecraft, here's all the old data from the Java job that we ran. So let's just go ahead and remove all of that. So now it's empty. It's ready to be used by our brand new Minecraft server running on Docker. So we're going to look for the client with the volume named Minecraft that's configured. And then we're going to run our task using the Docker task driver. And so we're going to specify our volume mount stanza, which volume on this host should we be mounting and what should we be mounting in it. So we're looking for the Minecraft volume, and we've configured that up here in the group block. And then within our container, our Minecraft container, which directory are we mounting or putting our data into opt/Minecraft, and that would be /world. Then we have our config block, unique to the driver we're using. So because we're using the Docker task driver, this config block needs to be configured the way that a Docker task driver would require to be configured. So what image would we like to use? And by default, we're going to pull this from Docker Hub. So we just provide the namespace itzg /Minecraft-server. If you're not familiar with that container image, right, out on Docker Hub, you can go ahead and look this up. This is where that comes from. You can look at all the documentation. And it's a very popular Docker container image that is used for Minecraft servers. And then we're going to pass in our ports that our container will be exposed on. And MC vanilla port and MC vanilla archine are those ports that we configured up here. And then we have our resources and then environment variables. And these environment variables are going to be provided to Docker when it runs our container. And because the container, according to the itzg documentation, has an environment variable called EULA that must be set to true. This is required. we're going to go ahead and provide that. So I'm going to hit save to save this template. And now when I go to jobs and I hit run job, I can choose that Docker Minecraft template. So I'm going to hit apply and I'm going to hit plan. And then Nomad has discovered a client that has Docker installed and meets the requirements for this job to run. So we're going to hit run. And we're downloading our image and our task has been started. So we'll wait for the new allocation to go 1 of 1, running and healthy. And there it is. So let's take a look. Let's look at our task and view the logs. And the Minecraft server is attempting to set itself up. So my Minecraft server has finished setting itself up and I'm ready to connect to it. But for some reason, my world directory still has not populated, which tells me something is not working the way I would expect it to. So let's take a look at my job definition real quick. So I made a mistake. Normally when you launch Minecraft, the world data gets put into a directory called /world. However, because we are using the ITZG Minecraft container image, that has been modified. So if we look at the data directory structure, everything now sits within data, including world. So I actually need to change my definition to use /data. So in my job, I'll come up to definition, I'll hit edit. And then within my task, volume mount stanza, I'll change this to /data. I'll hit plan and I'll run that and it will change it. And then I'm going to go ahead and go back to my template. I'm going to hit run job, choose from template, manage the Docker Minecraft template. And I'm going to modify this so that I don't make that mistake again in the future. So Minecraft is running again, but now I should be able to see all of my data mounted, and there it is. So a simple case of misconfiguration. So now with the Minecraft server being orchestrated by Nomad, running as a container on this system, I should be able to do Docker PS. Yes, I see the Minecraft server. And then I'm going to go ahead and launch Minecraft, and I'm going to attempt to log in. So again, making sure my client version matches my server version. I'm going to hit play. So I'm going to go to multiplayer. I'm going to edit my Nomad server, make sure that IP address still matches the IP address of my Linux server, and it does. Now, if you're doing this on your local computer, obviously you're going to do localhost port 25565. I'm going to hit done. And looks like I didn't follow. Looks like I'm not practicing what I'm preaching. And now I noticed for this particular version, I actually used the version 1.20.2 for the server. So let me go ahead and fix that real quick. So I'm going to relaunch the Minecraft launcher. I'm going to choose latest release that matches multiplayer, try to connect. And there we are. Now I'm connected to my Minecraft server that is being run by Docker, orchestrated by Nomad. And we're using volume mounts, so our data is persistent.